Good morning, Dr. Bang and everyone. We are the Romanian groups. Today we are going to present our project, the sequential control of a rotary table. The core problem we need to solve here is a technological constraint. For the input, we need to execute a complex sequential logic, counterclockwise and clockwise. We are not allowed to use PLC or microcontrollers, and we must build using only intermediate relays. Moving to the mechanical design idea, we didn't just choose a random shape, we went through a design evolution process. So we started with a few sketches to visualize the sensor positions and the table shapes. As you can see here, our first 3 iterations failed because they were too bulky and hard to adjust. We optimized the final design based on constraint, so we chose the base plate to have a diameter of 120 millimeters, and the rotary has to be smaller, so we chose the diameter of 80 millimeters. Here we recheck the motor mounting to see if it's safe enough. So to verify if the motor can handle the direct drive mechanisms, we perform a dynamic analysis. With a 50-gram acrylic disc, we calculated the required torque to overcome inertia and friction. Here is the answers, and we need to find the safety factor in order to know if the motor is usable or not. So we chose the N20 worm gear motor with a ratio of 236:1 to minimize the backdrive, and the number will be slightly different as we buy from different sellers and different data sheet. So we will take the mean value, which is 70 RPM. Here is the verifying calculation. Even calculating at a speed of 70 RPM, the required load is still extremely small, only about 0.0075 kg/cm, and the motor provides 0.3 kg/cm, so we can calculate the safety factor is 40, which is more than enough for this application. Here are the list of the materials. The first table comprises the main components for the table, and the second table shows the electrical accessories that we used. For the hardware architecture, we used 3 isolated voltage domains, 24 volts to supply for the sensors, 220 for the logic, and 12 for the actuator motor. This ensures galvanic isolation and safety. The 24 and 12 volt sources are generated from the respective switching power supply. This is the core logic, the SFC chart. The system must choose between the 2 branches, clockwise or counterclockwise, based on the user's initial input. To translate that into the hardware, we designed this relay logic circuit with 3 key blocks. First is the state memory with the relay 1 to 4 to remember the current position sequence. Second is the H bridge, using the relay X and Y to reverse the motor polarity. Finally is the safety interlock mechanisms, so we wired the normally closed contacts in series in order to ensure zero shoot-through risk. This is a CAD simulation interface with a full relay schematic. Here is our final model. Now let's verify the operation scenarios. We have the first scenario, which is the green button in the clockwise cycle. We go from H to A in clockwise, to B in counterclockwise, and back to H in clockwise. When we press green, the table rotates clockwise from home to A, as we can see here. Note this behavior. As it passes sensor B, the system ignores it. This proves our state memory logic is now working correctly. Upon reaching A, it reverses to B, and then reverse again and returns to home. Now for the second scenario is the red button, which is the counterclockwise cycle. We go from H to B in counterclockwise, back to A in clockwise, and then back to H in counterclockwise. The interlock logic successfully switches direction instantly without short-circuiting. Again, we move from H to B, and when it reaches A, again, it is ignored. Reaching B, back to A, and then back to home. To conclude, we have achieved the following. For the functionality, we have successfully controlled a complex sequence using only relays. For verifications, the physical model matches the calculations and the simulation perfectly. In the future, to address the bulkiness and the mechanical noises, we propose upgrading to the solid-state relays or using a microcontroller for the next iteration to reduce the wiring. Thank you, Dr. Bang, and everyone for listening. We are ready for your questions.
Rồi những trường hợp không hỏi cả hai nhé, rồi một lần cả hai nhé, cả hai rồi lần nấu một lúc không? Ok rồi.